Hello and welcome back. Today on the bench is an old valve tester that I built ages and ages ago and recently I decided to gut it and start again. There's a few things that were wrong with it. It was basically built as an basic emission tester, so nothing fancy, using a patch bay as to select the various pins on the test sockets instead of loads of switches. Obviously you can see we've got a load of panel meters to register the various voltages. They want looking at. As you can see, this one here, needle stuck up there. I don't know whether that's because of the, yeah, that's just the offset, and it sticks as well. Yeah, it's not perfect. The design originally wasn't perfect. Anyway, ages ago, this is I think the first transformer I wound, and it's way over spec for this job. It's absolutely bonkers. It's got two 270 volt AC windings, which gives you about 350 volts DC when once rectified. I tested it because I can't remember what spec I wound it to, but looking at the winding wire in there, I can see that it's of a reasonable gauge. I tested it the other day and tested it at each high voltage winding at nearly 600 milliamps, which is way over spec. I mean, that must be getting on for 500 VA, 500 watt, something like that. However, if we're flexible, and basically what I did before was, and I'm going to do the same here and have done the same, if I build two variable high voltage power supplies, then I can use those high voltage power supplies with my big bench power supply over there to build amplifiers, test and build amplifiers, things of that nature, rather than having, like you saw in my last video, lots of transformers all over the place. So as mentioned, this has two beefy high voltage windings on there. There's a very weeny bias winding of 30 volts and a heavier gauge DC a heavier gauge winding 30 volts, and that's capable of doing about 3 amps. Obviously that's for our heaters, and that's really all there is to it. So I built a couple of new variable power supplies the other day using this circuit, which is very simple. I wanted something simple because the more complicated power supplies I've built, like this one, they just don't behave as well when testing volts. You don't need nothing fancy for testing volts. This one was basically got a lot of protection built into it, so if the whatever we're testing pulls too much current, it shuts itself down. I don't know if this would do that in such a fancy way. I mean, I've been through this circuit before in that I've used it for the screen grids, regulated screen grids. So yeah, as you can see, my usual construction, using a Dremel, I cut out all the tracers. Everything's surface mounted for ease of construction again. We've got a bridge diode, big capacitor, got a big 200k resistor across those to act as a bleed resistor, and then all the other resistors and whatever, all the other components are there. Makes the construction just loads easier than having to drill loads of holes and all the rest of it. It doesn't look as nice, but who gives a damn, eh? It's going to sit in there. I'm not really going to be looking at it much. One thing I will make a point of, I recently bought this copper clad board from a supplier in the UK, a shop. I won't mention them because it's not fair. It was cheap, but this stuff is crap, utter crap. When I was soldering today on there, where was it? This one or the other one? I was repositioning the diode because I'd put the diode on wrong. Where is it? It's on this one. No, we can't see it now. Oh yeah, you can. Yeah, there. You can see that. Repositioning this diode because I got it on back to front. Just give a little bit of a tug and that pulled the copper straight off. With other boards, sheet board I've used before, that's not happened. As you can see, it's really thin, so wouldn't advise. If you see this white board, I would give it a wide berth. So that's enough rattling on about the high voltage power supplies. We'll test them in a minute. So what I'm going to do, I'm going to put those in there. So we've got basically one for the screen grid, one for the anode. As mentioned, these are way over the top for what they are. But if I box clever, then what I can do, I can make them stackable, make them floatable, in that I can stack them in the future if I want to give us about 700 or thereabouts, 0 to 700 volt supply if I want to. The other thing I'm going to have a go at with this is trying to fit a, what do you call it, GM measuring circuit on there. I'll find something online that hopefully will do the job, so I'm going to have a go at fitting that. In the past I used this supply here for the heaters. It's just basically an LM317 AHV, sorry, and I did faff about putting various presets and resistors in there on the adjust pin of the 713 to give us fixed heater voltages. In practice I found that didn't work, because what happens is with various valves that you're testing, obviously they got different current ratings, and I found they weren't accurate. They were all over the shop. If you haven't got a accurate heater voltage, then you can't really test your valve properly, can you? So I'm just going to make that variable, which is what I used it as loads of times previously. I might fit a short tester, but to be honest I don't know as I could use it, because what I've noticed is if I have tested a valve that has got something like a heater cathode short or something like that, then how the current on the meter and how the voltage readings on these two meters react gives me an indication of any faults that the valve has, physical faults. Yeah, the other thing I did was make a really simple bias supply, just using a couple of caps, bridge rectifier, and then just put the output of that through a pot and just adjust it that way. Don't know if that's a good idea. It wants something a bit better than that, I think. And the obvious thing that is missing here is a ammeter. What I've done in the past is to put the output in series with one of my flukes and use that. So we could do with an ammeter really. And on the subject of which, I've got these little things. This I think measures 300 volts and quite a few amps. The problem is though, because it's really designed for measuring amps and not milliamps, the resolution isn't very good. So that we can't really use that, although I might fit something like that in the future. Let me sit down, legs give me jet. So yeah, we need to fit an ammeter. And the other thing is, I think it'd probably be a good idea to redesign this whole. It would probably be a good idea to redesign this whole panel. One thing though, a lot of the valves I test, well, all the valves I test more or less are audio valves. Things like ECC 83s and audio output valves. A lot of the time, when you're testing them, you're only testing the anodes and all the other and screen voltages at or about 300 volts anyway, so we don't really need that capability. However, you see, what I'm trying to get at here is you can over design something and make it more complicated than it need be. I could just chuck these two supplies in there and use it as it is, really, without all this faffing about and getting clever. But then and again, it is nice to have a bit of flexibility built in. So I'm going to go and look at what sort of bits I've got, meters and whatnot, and then I'll make a final decision on what I'm going to do, because I don't want to make my life too difficult and start getting into a big project that I'm not really set up for, because my legs are still not properly healed, although I can stand up on them now, which is good, but I still can't walk. Right, so that's it for now. More later.